away we go. So we started the other day, 7.2 integral substitution, and we took a look at it. We'll do a quick review here. Indefinite means not from 3 to 5, not from A to B. A definite integral is from two values, from A to B, from 7 to 12. And you get an area trapped between the x-axis and that curve from the starting value to the final value. Could be positive or negative. Here, indefinite, no numbers. It's just the general solution, and this is sort of like the antiderivative idea, right? And that's why we have the plus c, and we talked about that. Because the whole family of antiderivatives could be x squared minus sine x plus 0, could have been plus 13, could have been minus 7/4. Okay, enough about those. We talked about that. We went through a few examples, making sure if you got du and dx and stuff like this, making sure that those variables match, just like with derivatives, right? Then we talked about substitution, and I said, unless you try some of these, it doesn't really make sense, and you're going to have to get some time to try this. You use it for composite functions when you can't see an easy solution. Just like when I say sine x, you guys say that came from, like the integral, indefinite integral of sine of x, negative cosine of x, plus c, plus 5, whatever. An antiderivative is negative sine x. The indefinite integral, though, is plus c. Now, those are easy ones you can do by sight. If you have an inside, I was saying, think of it that way. That's where you let u equal x cubed, for example, in this one. Do the derivative, but separate the du and the dx. Then sub back in. You should have a simpler integral to do. Do it. Last step, sub back. We did another one here, too. Okay? Now, Mr. Joe contacted me the other day because he was worried I'd forgotten to do a shout out for you girls when you were gone. I didn't, because I heard, if you guys heard about the Dundurn Mega Mall, the Brighton View Corporation is buying land at the Global Transportation Hub. You guys know about that?
Yeah, of course. Yeah.
Well, after the, you know, in November there was the U.S. That big referendum or whatever, where they decided that they really hate the pantsuit. Or do you know what I'm talking about? In November, Trump won, Clinton lost. Anyways, she's moving to Canada to open up a whole new line, Lady Foot Locker, the pantsuits and stuff. And I heard, the reason why I didn't want to spoil it was, shout out to these girls now that they're here. They were also, Ali and Tanjay bought a line of stuff, power suits and stuff like that. Anyways, it should be good. And the Dundurn Mega Mall, when it opens, it's going to be the only mega mall, only one in North America so far, that will have 5 taco times in the same mall. Anyways, I'm going to skip this one right now. And there's a reason why. Trigonometric substitution is a type of substitution. But as far as I know, and we were safe last year, it's not used often on the AP test, and I think you can get around not using it at all. It's not really on the curriculum, so some teachers are like, I think it should be done. I don't. But be able, as far as memorizing identities, do be able to memorize the reciprocal identities, quotient identities if needed, and the Pythagorean identity. Those are the ones you're assumed to know as far as I know. You don't need double angle ones as far as I know. I'm not guaranteeing that. So I'm going to skip this one right now. We might come back to it, but I just wanted to give you a word class, so I'll give you one example. Evaluate a definite integral. Now this is a definite one using substitution. So we're back to 0. This is definite because it goes from 0 to 2, right? So I didn't want you girls thinking that I'd forgotten. So, where we go. Just treat this like the other substitutions, but this is a new thing here. The 0 to 2, we'll keep this in mind. what is the inside function if you think of this one? Now this one, what is you might also think of it as the more complex function that if I do the derivative, I'll get parts of the other stuff. Yeah, so sometimes you think, if I let u equal x squared minus 9, what's the derivative of that? 2x, right? And then I'll be able to substitute in for that x. You can try to kill stone two birds with one rock or whatever, right? Okay. So I'm going to let u equal x squared minus 9. If I do that, we do the derivative. du, normally, I'd say, by dx. But you guys remember how we're doing it a little differently now? This is 2x. But I'm not going to write it this way. I'm going to separate the variables.
Jimmy and Annabelle Potts, please come to the office. That's Jimmy and Annabelle Potts to
Back
the
to
office.
this.
Thank you.
Now, if I do some substitution, you probably see this is a direct substitution. It'll be u right here. This x and dx is what I need, right? Now, if you like to solve for dx, go ahead and do that, and then you'll see that you'll be dividing by 2x, and it'll come out. I like to think of it as keep this stuff and move this half over there. That's the way I think. So here's what I'm thinking. I wouldn't always write it out, but you probably should, because I'm prone to make a lot of mistakes. So I'm going to substitute half du in directly for x dx, right? However you want to do it. But there's a problem here. So I do all this subbing here, right? So this becomes, now, 0 to 2. I'll come back to those. I'm not going to write them down now. So I've got x dx replaced, so x and dx is replaced by 1/2 du. Let's just toss this out here. 1/2, I'll space it, du. That takes care of the numerator, right? So this is really a 1 now when I put this in there, right? Now I'm going to let the green one stand there, but you guys understand where that's coming from? Yeah. X squared minus 9, I said that's going to be called u. Now you might, I think of it this way, you might think of it better. There's a couple things. Think of the number 1/2 over at times 1 over u. This is maybe more apparent. In 1 over u, okay, we'll get back to the antiderivative part of it in a second. Before I go on though, I said 0 and 2. What is it assumed if you had the antiderivative for that function x over x squared minus 9? You would be plugging in for x the value of 0 and for x the value of 2. So that means this is the limit when x equals 0 until x equals 2. We have to change these to u equals. You guys follow me on this? So here's what I'm going to do, and maybe see this. So when x equals 2, that's the top limit, the upper bound. What does u equal? Well, we put it in this equation, u equals x squared minus 9, right? So 4 minus 9 is negative 5, correct? You're using a calculator? Oh, good. Okay. X equals 0. When I toss that in there, u, that corresponds to a value of negative 9, right? Guaranteed. So my limits change from negative 9 to negative 5. Now, the other day I mentioned this with the antiderivatives, and this is where it's true. What is the antiderivative of 1/2 1 over u, where u to the negative 1? Involves the natural law. But Tristan's making what I mentioned the other day. I've been lazy when I'm doing antiderivatives before, not emphasizing the absolute value. Here you definitely have to, and it's very apparent because you're using negatives. You can't put a negative in a log expression, right? because the graphs, if you recall, graph looks like this. There are no negative values. So we have to use absolute value. Then it'll mean that side too. Right? Okay. So what I'm saying is that this is equal to, from the fundamental theorem of calculus, the antiderivative, 1/2 of, I'll do this first, natural log of mu. -9, -5. Does that make sense? Now guess what? When you were doing indefinite integrals, your next step would have been to sub back in for your x, right? Or your u value equals x squared minus 9. We don't have to here because we already have, we can just plug in -9 or 5 and come up with the answer. Does that make some sense to you? Until you do a few, I won't buy that for sure. So our final answer here, our exact value is 1/2 the natural log of 5, absolute value, right? Subtracting 1/2, I guess I could have had the half out the front and had brackets. The natural log of 9. If it's a calculator section on a test, you might be asked to evaluate at the 3 decimal places. That might be one of your 3 or 4 choices, right? If it is a not calculator section of your test, that's a weird way of saying it, a not calculator section, you would probably have this expression cleaned up a little bit. Now, I don't know why I multiplied through the half right away. I should have kept that out in half, and then natural log 5 minus natural log 9. When you are subtracting logs, it's really the rules of exponents. So what does that mean? Division. So this would be 1/2, but then what? Okay, we don't need the bracket. Okay, we could have brackets, natural log 5 minus natural log 9. But what is natural log 5 minus natural log 9? 5/9, but where? Is it just like this? Inside the natural log. Okay, good. So this means 1/2 the natural log of 5/9. If you wish to put it in a bracket, you can. It's understood to be that way. That might be one of your A, B, C, D choices. Does that make sense if you're given multiple choice? If not, I'd be fine with it just with the subtraction. You never know. Now, I've said to try some of these odds, eh? Skip 21, because I don't have any evidence of inverses being included, okay? I'll stop the process.